Okay, we are in Chapter 3 of Chemistry, and it involves chemical fundamentals such as elements, atoms, and ions. We will begin with the periodic table, which is composed of elements, which you might have remember from physical science. Everybody should be in possession of a periodic table, and you can see that each of those little squares represents an element and has information about those elements. The most important element is carbon, and you learned about this in biology. Carbon makes up living cells, so that's vital for life. Okay, other examples. We have iron and aluminum, which, as you can see, billions of these products are produced yearly, so there's great economic significance. It's a lot of building materials, so generating a lot of money. In the Earth's core, we have iron. Fe is the symbol for iron. Now, you need to know the 9 most abundant on Earth. We have oxygen, which is in the air you breathe. Silicon is in a lot of computer products. Aluminum, building materials, and also aluminum foil, which you might know from being in your house. We have iron, the most abundant of all. Calcium, which is in bones or in milk. Sodium is in salt. Potassium is in bananas. Magnesium is in such things as fireworks. And hydrogen composes water. Okay, so these are the most abundant on Earth. Iron is the most abundant of all, and the most abundant on our planet is oxygen. Okay, also from biology, the 4 elements necessary for life are oxygen, carbon, hydrogen, and nitrogen. And you learned about these when we studied biomolecules like DNA, proteins, lipids, carbohydrates. Okay, now this was referenced in the last chapter as one of your test questions. We asked you how many atoms there are, and the answer was roughly 100. This is referencing the periodic table. It's not quite 120. I believe it's up to about 118, and 88 of those are natural, which means that you can find them on the planet, and the rest of them are synthetic or made in the laboratory, which is why some of their symbols might be clear. And just a little note, this is 2013, September. In the news recently, we learned that element 115, you have to do some steps to make sure an element is real. So all of those steps have been taken, and now 115 will now get its name pretty soon. So big news story. Okay, now just a little note on symbols here. How come some of the symbols don't match the names on the periodic table? Well, it's because the periodic table is not written in English. A lot of these are referencing other languages. So let's go down the list. AU is referencing Latin, so the Latin word for gold is aurum. Personally, I think the Old English is closer with giolo, which means gold, but they stuck with Latin. Who came up with the table? Ag is silver, the Latin word is argentum. K for potassium, the Latin word is kalium, so there's the K. Pb is lead, from plumbum or heavy. And I have 2 ways to get you to remember lead. Pb for plumbum is like plumbing, or if you think PB peanut butter, it's kind of a heavy food. Yes, I know. You're welcome for that. Okay, Sn is tin, from the Latin word stannum. And here we have a different language now. German, Wolfram is the W that represents tungsten. And another little side note, tungsten is in your light bulbs. It's the little filament that allows the light bulb to last for a long time because tungsten has a fairly high melting point. So yes, you have tungsten in your homes, but don't go staring at light bulbs. Just so you know, it's the filament inside a light bulb. The next 3 are coming from the Greek language. Cl is chlorine, I is iodine, and Br is bromine. So chlorine and iodine represent colors, and bromine is for a stench. And now we get the ones that make a little bit more sense, but that's because these are made in a lab, most of them. So their names were chosen by a group of scientists. Am is for America, Americium. Cf, Californium, for the state of California. Ge is germanium, or Germany. Po is polonium, or Poland. And Fr is francium, or France. Okay, more elements that are made in the lab usually get named for famous scientists. So Es is Einsteinium for Einstein. No, Nobelium for Nobel, the man that created the Nobel Prize, also dynamite. And Cm is curium for Marie Curie. famous woman scientist. Thank you very much. Okay, and we'll finish off here with writing symbols. Make sure when you write your element symbols, you use a capital letter for the first letter and a lowercase letter for the second one. So please watch your handwriting. Okay, I will take off points if you don't use a capital and a lowercase letter, so be careful. Okay, and then we finish up here. We taught you in the last chapter that elements or compounds are pure substances. So we've been talking about elements. They're on the periodic table. But make sure you remember that a compound is two or more elements chemically combined. And you need to remember they're combined in a fixed proportion because this is actually a law. So if you look right here, it says the law of constant composition. Compound always has the same composition no matter where it comes from. So I believe I taught you this, H2O, always two H's, always one O. Any scientist, any country should be able to recognize that. If you add something like another oxygen, like H2O2, then you have something different, that's peroxide. CO2 is carbon dioxide, one carbon to two oxygens. If you change this at all, let's say you take away that one of the oxygens, you now have carbon monoxide, which is a poisonous gas. So compounds have to be in a fixed proportion.